So we're going to prove the property of logarithms that says the logarithm base a of the quotient of x and y is the same thing as log base a of x minus log base a of y. So the first thing we're going to do is just define what our x's and y's are going to be. So I'm going to say that x is just some number, and it can be represented as some other number to a power. Likewise, I'm going to say y is another number that can also be represented by some power of a, but just a different power of a, because it's different than x. So just by the definition of that exponent, I'm going to rewrite these as logarithms. So this is saying the exponent that you would place on a to get x is m. And over here, as a logarithm, the exponent that you would place on a to get y is equal to n. So we've just rewritten our x and y in different forms. So now I'm actually going to say the log base a of x over y. I can rewrite that, and instead of using x and y, what we're going to use is our new definitions of x and y. We called x a to the m, and we called y a to the n. So instead of x divided by y, we are going to take a to the m and divide it by a to the n. Now, on the right side, I'm going to simplify a little bit. When I have the same base on these exponents and they're being divided, the little shortcut or the property of exponents says that we could simply keep that base and subtract the exponents. I didn't do anything with the left side here, so I'm just going to rewrite it. Now, looking more specifically at this, we know what this is. The logarithm, the definition of the logarithm, is asking us what power of a would give you a to the m minus n. Well, it's clear to us then that that power must be m minus n. So we're going to take this entire thing here and rewrite it as m minus n. And that's still equal to our log base a of x divided by y. Now all I'm going to do on the left side, again, we're not changing it because we want to prove something about that, so we're going to keep it there. All I'm going to rewrite my m and my n from above, and I'm going to be selective. I want it to look like this, so I'm going to choose these definitions of m and n. So my first m, instead of writing m, I'm going to call it the log base a of x. And I need to subtract n, and instead of n, we're going to call that the log base a of y. So we have successfully proven that instead of taking the log of a quotient, you can find the difference of the individual logs of the numerator and the denominator.